Welcome to IBM System Values. Set the tone for security. My name is Amy Williams. I'll be the presenter today. I'm a principal security consultant with Fortra. I achieved my second year of IBM Champion, and I have held the CISA and the CISSP certifications for a number of years. Today we're going to talk about system values and what part they make up of the security posture on your IBM. We're going to go through a number of recommendations, so there will be a lot coming at you today, and hopefully we can cover all of it. And then I also want to touch on a few little extra bits. So we're going to look at function usage, and we're also going to look at securing Navigator for I. So when we talk about system values, setting the tone for security on your IBM, system values play a key role in the overall security of your system. Now, it really is a three-pronged approach where you have user profile settings, you have object authorities, and you have system values. And we're going to talk about some of those system values that actually can get overridden at the user profile level. So when you talk about setting the tone of security on your system, you want to be thinking about not only the global settings, your system values, and how they will allow the system to behave, but you also want to think about how those might get overridden at the user profile level, and if that is or is not appropriate for your environment. The system values that we're going to cover today are all on this list. So there's a lot of them, and like I said, we're going to be going through these in some detail so you can understand what effects they might have on your system. Now, I've also marked those with an asterisk that can be overridden at the user profile, and we'll talk about those as we go through the presentation. Now, with all of these on here, you're probably thinking there can't be many more, but there are, and these are some of the ones that I'm just not going to have time to get through during today's presentation. But they are values that you should take into consideration when setting up your system. So what are all the recommendations that we're making, and why are we making the recommendations that we are? These recommendations are coming from years of experience in helping customers harden their systems, and also from some of the standard best practices that have been documented throughout NIST, ISO 27000, and now the CIS benchmarks. So the very first thing on IBM is your security level, and it truly does start the tone for everything, because this talks about integrity checking, how user profiles can work with each other, and what kind of default authorities might be granted. So level 50, which is the strongest security level for IBM, was developed with the military and government in mind and meets common criteria requirements. Level 40, which is the level that the majority of systems are running at and is the default shipped by IBM, this provides additional operating system integrity enforcement where you cannot bypass the IBM APIs to be able to call system programs or to be able to interact with those objects. Level 30, QSEC offer class profiles were the only profiles granted all object, and this is also true at level 40. What is different at level 30 is that there is a way that you can access user profiles through job descriptions without having to have private authorities set to those user profiles. Now, the reason we highlight this is because the biggest difference between level 20 and level 30, when you make that move, at level 20, all users are granted by default at creation time, all object and save sys. When you do that IPL and you change your Q security level from 20 to 30, all of those authorities get stripped away from all of the users except for those in the sec offer class. So that's why that's highlighted on this slide, is to really drive home the fact that level 20 right now is the weakest. Level 30, you're at least not granting all object to all users, but you do have some exposures to authorities that could allow for user profile impersonation, level 40 is really where you want to be. So what are some of those steps, some of those considerations to get from level 20 or level 30 to get to level 40? Well, the great thing about IBM I is it actually lets you configure the system so that it is operating as if you are at level 40, and it will alert you in the audit journal if those things that would break at level 40 are occurring. So monitoring for those authority failures, updating those job descriptions to ensure that you don't have user profiles that could be exploited, and updating any of your applications if required because they are not using the approved APIs to access the system objects, but they're going directly to those objects as you could prior to security level 30. Now, if you're at level 20, I already mentioned that all object and save sys, those special authorities will be removed from all users that are not in that SecOffer class. So you really need to determine what authorities your users need. Remove all those authorities prior to going to level 30, so it really is a minimal change at the time that you do the IPL. All of the authority checking algorithms, whether you're at 20, 30, 40, or 50, those checking algorithms work the same way. And again, it is a huge advantage because you don't have to do an all or nothing change and hope for the best. You can prepare your system through those secure configurations to ensure that when you perform that IPL, it is a non-event. And that's always our goal. Some of the other things that you're going to look for when you're moving from 20 or 30 to level 40, you're going to ensure you have program fail and authority failures in your audit system value. And those are going to allow you to log those events that I mentioned that at 40 will be a halt, right? They will stop that application, that job in its tracks. But at level 20 and 30, it's just basically an informational message about this authority failure potential. And I've listed the different AF type entries that you're going to be looking for. So the J is for those job descriptions, D is for domain failures, and then there are four others that you can possibly experience. But the two that we experience the most are of the job description and the domain. Password system values. Failures. So we talk about passwords a lot. People are talking about eliminating passwords, which would be amazing. But there's still times that we're going to have user profiles with passwords on our IBM I systems. So today, the shipped value by default is 0. And that gives us very limited ability for complexity. And it also exposes a weakly encrypted version of that password hash when you're at level 0. And this weaker version was required back when Windows 95 and XP were still in service. And I think we're almost a couple of decades now away from when those were common practice in business. So moving to level 1 is a non-event. It does take an IPL to do this, but it's not going to change any of the passwords, but it does remove that weakly encrypted version of the password hash. When we move to level 2, that's when things start getting more interesting because now we have case sensitivity. We've got up to 128 characters. So we can see that just being able to put in a password that's longer than 10 characters is really important. The length of that password is truly what makes it stronger, even more so than having a bunch of weird characters in it or doing a bunch of funny things. Having that passphrase, the more characters, it really does help prevent somebody from being able to guess or crack your password. Again, though, at level 2, that net server password, that weakly hashed version is still there. So once you're good at level 2 and you've found that you don't need to go back to level 1, IPLing and going to level 3 is really the best place to be. And it is the same as level 2, but again, like level 1, it gets rid of that weakly encrypted version of the password hash. Now, level 4 was introduced in v7r5. The big thing with password level 4 is that it does now use a higher encryption of SHA-512 so that the hash is even more protected. Some other considerations, if you have your own applications that might be using password substitution, they may have to be reworked to become compatible with this new password level. So when we talk about complexity, right, we talked about length, and that is really important. But when we talk about the way that we compose those passwords, we can encourage our users to have stronger composed passwords, right? So what I've got here is the shipped value for the QPWD rules system value is password sysval. So that password sysval is going to look at the password min length, the max length, the required digit value. There's a number of others that we're going to look at on the next page. But if you start using password rules, you can likely make your complexity rules very close to what your Windows environment is set up to be. I also like it because by using just the 4 values that I've outlined here, by requiring any 3, which means it has to have 3 of 4 components. It has to have an uppercase, lowercase, a digit, and a special character. As long as it has 3 of those things, it's going to pass that require any 3 requirement. Then we want to make sure that it's at least 12 characters, right? That really is the minimum these days of good passwords. I know that NIST has 8 documented, but if you really dig in, there are a lot of caveats about how you have to protect those passwords if you're only using that minimum number of 8. The 2 special values that I've also included, all create change and limit profile name. Now, all create change, this means even a user with all object, special authority, and secadmin cannot set a password that does not meet the complexity rules. So no more of just setting a single character password for those profiles that you want to manage yourselves. These profiles will still have to have a minimum length password of 12 and have upper lowercase, a digit, special character included. And then limit profile name, this means that anywhere within the passphrase. So if you have a passphrase that might be, Amy did a great job, and my profile is Amy, that password won't pass because that it includes my profile name within it. So not only is it going to prevent default passwords from being able to be created, which of course the min length also does, but that will also prevent it from being able to be an easily guessed password because no component of the password will be identifiable just because of your user profile. If you're going to use the password system values, again, a minimum length of 12, the shipped value is 6, maximum length of 128, the shipped value is 8, and requiring a digit, we do suggest you turn that on if you're using password sysval, and the shipped value is to not require a digit. So when we look at all of the values that you can use with password rules, right, we can limit adjacent characters. We can say that it has to have a digit. It can't have a digit at the end of it, or it can't have a digit at the beginning. We can say that it can only have 1 digit, right? Or maybe it has to have 2. There are a lot of combinations, and this is why I say you should be able to make these rules very similar to what your Windows environment is. And the less our users have to remember how to compose different passwords for different applications or systems, hopefully the less likely they are to write these down and make them easily vulnerable. So some other things to think about when you're talking about passwords, it goes beyond complexity. So password change block, this means that the user themselves cannot use the F9 on that sign-on information screen to change the password, within a certain number of hours. The shipped value is none, so they could immediately change that password again. Our recommendation is that you set that for 24 hours. Password expiration interval. So this again is shipped at no max. We recommend setting this for 90 days to keep good password health. Now, I know that some policies are now moving towards changing only once a year or changing every 6 months, unless there's an incident or the user knows that their password's been compromised. I would argue that we don't know how our users are using their passwords and if those passwords have been compromised or not. Having stale passwords that could be published or bought out on the dark web is just bad practice. So having them refresh those passwords more often, I think is a better way of ensuring a compromise can't happen. And then warning them when that password is about to expire. That shipped value is 7. We recommend giving them 2 weeks of warning. And then requiring them to actually set the password to a different password. So if you have all these other values set up and you leave the password required to be different at 0, which is the shipped value, I can set my password right back to the exact same value and the system will count that as a changed password and I can go on my merry way. Setting that to a value between 1 and 8 that have different correlations of how many different passwords that requires will really ensure that at least they're not using the exact same password over and over again. So some best practices. So I've kind of harped on the minimum length, so at least 12 characters long. Really trying to make those longer so that any of those, password attack methods that are out there, they have a lot harder job and a lot longer to take before they can crack those passwords. Containing a number, containing upper and lowercase characters. And again, this is where a special character, upper, lowercase, containing a number, having those complexity rules will make it hopefully easier for your users to create a memorable password, creating a passphrase, without having a lot of overhead on what those rules are. Changing them on a regular basis, right? So you can override this. This is one of those that you can override at the user profile, is how often they have to change their password. So if you have service accounts, we're going to talk about in a second. If you've got special users that, you've got contractors, you want them refreshing their passwords more often because you don't know where else they're using those passwords. They shouldn't be known to the administrators, obviously. And then trying to remind users not to share their passwords with others. So we'll talk about some ways you can control that also. If we make creating the passwords too difficult, they're going to write them down. They're going to be on a sticky under their keyboard. I wish that was still just a joke from the 80s, but it's not. It still happens today. So making the rules more common, having it similar to the way they're creating their passwords on Windows, it's going to make everybody's lives hopefully a little bit easier. So service profiles. These should be a more complex, and when I say more complex, they should be longer passwords. These are not being changed on a regular basis. We do recommend changing them on a once a year basis. This is not only good password hygiene, but it is also a good disaster recovery practice. I can't even count how often we would run into a situation where either a system was down or a connecting service had to be rebuilt and nobody knew what those passwords were and they didn't know where they were stored. So putting this kind of a hygiene practice into place and regularly changing those service accounts, knowing how to change those service accounts, knowing what processes are dependent on those user profiles and on those passwords. Super important. Definitely recommend having some sort of a secure area to be able to store those passwords in. So keeping them in a password vault and not reusing the same passwords for multiple service accounts. I know it sounds easy and nobody will figure it out, and it's great because now everybody knows. But right when I say now everybody knows, that is just now made that password and those services super vulnerable. So let's try and do better. So we've talked about the passwords, we've talked about authentication. That's how, we're allowing people into the system. But now what happens when they actually sign on? So another value that can get overridden at the user profile level is the number of attempts allowed before some action can be taken against the user profile at version 7.5 to either disable it and disable the device. So the shipped value for the max sign is 3. Our recommendation is between 3 and 5 attempts before an action is taken. The ship value for the action to be taken is to both disable the profile and disable the device. We recommend at minimum to disable the profile. The display sign-on information, and this again is where you can do that F9 to change your password, but we do recommend that you turn that on. By turning on the sign-on information, it'll allow people to know the last time that profile was used and signed on to the system, which could alert somebody to their profile being compromised. Next, we're going to talk about limit sec offer. So this is actually shipped turned on, meaning that any user with all object or star service is required to have explicit authority to the device they're signing on to. So when you first start up your system, you're always going to be able to sign on to the console with QSec offer. After that, you have to explicitly authorize QSec offer or any other user profile with all object or service private authorities to devices they're going to authenticate to. Often this gets turned off. I do suggest working towards getting it turned back on because it does limit that risk landscape of when an all object profile, if it gets compromised, it's going to take more information for them to be able to actually exploit it. The limit device session is another value that can get overridden at the user profile. This is shipped at unlimited. You can have a lot of sessions all going at once. Generally speaking, users don't need more than 1 or 2 sessions at a time to perform their job duties. If they do, you can override that at the user profile. So you can give up to 9 sessions that they can be running concurrently. And these are green screen, sign-on 5250 sessions. So something to think about. Having unlimited sessions, there's just not a really good reason for that anymore. So interactive job, right? So we've gotten our job started. We know how we're connecting. Now we've got a timeout to think about. So when that job's active, if there's no activity on it, right now, the way the system is shipped, there's no timeout. So that job can run for months on end if you don't IPL or end the subsystem or some other way. We really do recommend having that 15-minute timeout if your system can accommodate that. And some applications can, some can't. Having that inactive message queue set up for disconnect job rather than end job can allow for more recoverable sessions if they come back within a certain amount of time, but also setting that to less than the default that's shipped. So they set it for 240 minutes, so 4 hours. Setting that to 30 or 60 minutes means that not only have they exceeded the inactivity timer, but then they've also exceeded that disconnect timer. So that inactivity system value, right? We hear this all the time. We can't set it that low. The application can't handle it. The users are having, too much trouble. It's too much for them to re-authenticate over and over again all day. So putting in a good compensating control for those workstations, for those terminals and devices to ensure that the overall access to that workstation is being restricted with a timeout can be a good practice. So when we're talking about devices, right, and people are logging on, how do they get those devices? Well, those devices are generally auto-configured. So auto-config is turned on when you get the system, right? You first start it up. It's going to configure virtual devices. It'll configure your new controllers. When a new controller gets full, it'll configure another controller and more devices. The auto-vert is actually shipped at 0. So you've got to turn that on to start generating those virtual devices. We do suggest setting this to a number, 500, 1,000, whatever's right for your environment, so that you aren't necessarily susceptible to a DDoS attack where somebody starts generating device after device after device, and that can overwhelm the resources on your system and prevent you from having access to the system. Restoring objects. So how do we get anything installed on our systems? We're restoring objects to our system. So when that restore happens, we need integrity checking of those objects to ensure they are what we're expecting. So these 3 system values actually work together, and I've listed them in the order that they get checked. So the verify object restore, that gets shipped at 3, that is the best practice recommendation. So if an object has a signature, it's got to be the right signature. It has to be valid. So when we get past that check, the next one is, does this object need to be reconverted? Has it been tampered with? So when an object's compiled, there is a signature or a hash or some identifier that IBM can use so that when you're restoring that object to the system, it'll compare what's being restored to what was originally compiled. If they don't match and you have this turned on to 3, it will reconvert that to its original version. And then the allow object restore, we recommend putting allow PTF and allow program adopt in this. This will restrict objects being restored to your system to PTFs from IBM, right, that are stateful objects, and then programs that are configured to adopt authority. And let's talk a little bit more about the authority to objects and how you actually access them once you're on the system. So that default authority, that initial authority that gets set to any object that gets created onto the system, is set by that create aught system value. It's shipped at star change. Star change means that I can edit the data, I can change the data, I can delete the data out of files, I can manipulate data areas, right? Change is a pretty powerful authority to have on objects. Getting this reduced down to use, and then eventually even getting it set to exclude, is optimal because now public, which is the entirety of the user population, every user profile on the IBM I, is part of that public community. They have that authority to those objects. You don't necessarily want to do that. So when you start evaluating your system to be able to reduce from change to use, eventually to exclude, you're going to evaluate and break your libraries up, right? You've got your IBM shipped libraries, you have vendor libraries, you have your own application libraries, maybe query libraries, maybe developer libraries. Set those authorities on those libraries to be more restrictive so you're not affecting the entire system at once, but you can affect specific libraries. So what will happen then is that create value on the library will actually override what's set at the system value. So libraries by default are set to lib create authority. When you look at the library itself, it could have a create authority set of sysval, which means it's looking at that system value of qcreate-aught. And by default, it's star change. So if you actually change that create authority on the library itself to star use, you've now only affected the objects in that library. So you can go through your different libraries, identify the correct set of authorities, and then you can change your system value. So it allows you to slow roll those changes and not do everything at once and just hope for the best. So a little bit more about the adopted authority. So we can actually control who's allowed to create those programs that have the ability to run under the owner's authority. And this can be a pretty powerful authority. Adoptive authority means that when that program is running, so long as it's in the call stack and it's active in that job can run under that owner's authority, which could be elevated from what the user's authority is. This could be intentional, and there's good practices to use this format, but there's other things that could put you at risk. So ensuring that only those users that should be creating these types of programs or changing programs to have this attribute is really important. Putting an authorization list on the QU's adopt system value and having that set list of users is super powerful. So we've talked about our objects. We've gotten to our objects. Now, what about encrypting all of the data that's flowing in and out of our systems? So that's all controlled with the cipher list control system value and the cipher list itself. So we want to talk about how those are configured. Now, by default, at 7.4, V7R4, and V7R5, these are at best practice when they're set at OPSIS. You have a reduced number of protocols and ciphers. So those protocols, this is the third piece of the encrypted configuration. You've got TLS 1.3, TLS 1.2, 1.1, and then the deprecated protocols of version 1, SSL v3, and SSL v2. If you're at 7.4 or 7.5, the default protocols are going to be TLS 1.3 and TLS 1.2. And the cipher list has been greatly reduced to only those ciphers that are supported. If you're at 7.3, you could still have vulnerable ciphers in your list, and it will still default to have TLS version 1 in place. IFS. So we've talked about DB2 objects and that default create authority, but what about scanning our objects in the IFS and making sure that they aren't reinfecting our Windows environment with viruses or possibly being infected themselves? So at version 5.3, IBM introduced these two system values to allow for native scanning of the IBM I, where we can scan the root, the open systems, and the user-defined file systems. And that's what the root open UD stands for. With the scan control, by saying none, that means everything is going to get scanned regardless of how it's being accessed, whether it's being accessed by an RPG program or it's being accessed through the file server or through the net server. You can reduce the amount that's getting scanned by setting that to file server only. And there are some other valuable additional values that you can set to secure those activities. If there's an issue with your scanning program, if there are errors with it, it'll actually stop scanning and stop access to those files entirely. So we've talked about all these really important system values. What if somebody starts changing them? You can secure those system values from being able to be changed. And this is by using a setting in Service Tools or DST dedicated system tools, where you can actually lock all of the values that I've listed on the screen today from being able to be changed at all. Now, there's a number of these that we haven't even touched on, and that's how important they are to the reporting, the logging, the monitoring, and the security of your system. So to be able to lock these system values, you would sign on to SST, you would choose option 7 to work with the system security, and then you can set allow system value security changes yes or no. And that is going to lock those values. So even with all object, secadmin, you are not going to be able to change the values of those system values. Now, we've gone through a lot of good stuff, but I wanted to give you a little bit more content. So there's some great things that have come up in the last few years. So since V7R5, there's been some significant changes about the way the systems are actually shipped. No longer at V7R5 are profiles created with a default password. So prior to 7.5, when you create a new user profile, it would get created with a default password being the same as a user profile. Now at V7R5, that default is *none. So you have to set a password for that user profile. They've also secured the IFS even more, where previously you could enumerate the entirety of the home directory and see all of the directories regardless of your authority to those other directories underneath home. Now you have to have authority other than exclude to a directory within that home path to be able to enumerate it. And security level 10 is just no longer able to even create a user profile. So if you are actually still at security level 10, and we have seen this within the last 24 months, and you upgrade to 7.5, it's taken away that ability at level 10 where you key in a profile and you don't have to have a password. That's just not going to happen anymore. And when you do a restore and a migration to new hardware at 7.5, it will restore at level 30. And this is a consideration also for those of you that are running at security level 20. You can no longer set the system to security level 20 when you're at V7R5. And when you restore to new hardware, it will be at security level 30. So remember, at security level 30, moving from 20, all object and save sys gets removed from all profiles except those at a sec offer class. Let's have a little bit of fun. Navigator for I, right? They've done some awesome stuff with Navigator for I. I know I was never a big fan of the yellow bubble and how long it took to do anything, and it wasn't a lot of fun. But in the new Navigator, they have also brought us back to calling function usage. It was known as application administration, but function usage is another way that you can secure your IBM I. So it was created to provide a method for securing things like FTP, ODBC, and those functions. But now you can actually secure Navigator for I functions. So there are things like who can manipulate and create file shares or delete shares, who can work with the servers and network, who can manipulate user profiles or authorization lists and security, work with the system disk, SQL services, and the advanced job scheduler. All of those get controlled through different function usage IDs in Navigator. So I'll show you an example here where I've set the nav file system. I'm going to change the authorities on that, and I can select 1, 2, or 3 users or however many, and I can allow them or deny them access to that functionality. Even though they have Navigator access, they don't necessarily get access by default to everything. The other really nice thing that's happened is we can manage our system values from Navigator, and they've exposed these in such a way that it's a lot more manageable for those that haven't necessarily been in the IBM I world for a long time. So let's look at a quick demo that I pre-recorded so I wouldn't run out of time today. And what I'm doing is I'm showing you 2 different ways. So we can get the system values through the configuration. I'm going to scroll down to the security system values, and I'm going to right-click and go into the properties. This is going to show me all of those values that I can set through the security subset. So we've got Q security, we have the adopt authority, we have the Q create auth value. Few that we didn't go through, so allow user domain. But here's that scan control. shared memory, and then system TLS. So here's all of the cipher lists and those values that you can set to set those ciphers. Now, another way we can get there is through security and looking at the security configuration info. So this is going to be a little more familiar. You're going to see the different system values and the values actually reflected. Let's manage those password rules. So I'm going to set up my password rules so that we have that composition set up for the require any 3. So I'm going to change from using the basic composition tab to using the rules tab. So I'm going to flip that. And now I'm going to set my min length to 12, 14. I'm going to set my min length to 14. Then I'm going to go down and I'm going to say require any 3. You're not going to be allowed to have a profile in your password. I'm making sure that you have a minimum of 2 upper and lowercase characters. I'm going to enforce that everyone has to have a password that meets those criteria. I'm going to click OK, and then we're going to review what this setting looks like in the password rules system value. So we'll go back to security. We're going to look at configuration info. Scroll down to rules. I've got min length of 14, limit profile name, mixed case 2, require any 3, all create change. You know what? I don't think I want mixed case 2. I think I just want my min length of 14, limit profile name, and require any 3, and all create change. So let's change that again. So we're going to go back in. We're going to hit our composition rules, scroll down to the bottom, and I'm just going to remove that require minimum number of lowercase and uppercase letters. I'm going to hit OK. We'll validate that I finally made the right settings and that I'm meeting my requirements for that system value. So I've got minimum of 14. I'm limiting the profile name, requiring A3, and all create changes in place. Now I can sort, I can search, I can filter, I can change the column sizes. This has made it so much easier to manage so many of these system values in a really quick way. So here we can see just all the password rules just by putting pass into that filter. Again, a little bit different from what it is on the green screen, but at the end, it is the same values and it's still controlling your system in the same way. So hopefully I've provided you some interesting notes today. You've got an idea of maybe where your system sits in its security posture and how you might be able to improve it. We offer some great opportunities to help you with that. So we have our deep dive risk assessment or our security scan. And I always recommend, if you want to know more about the system values on your system, crack open that security reference guide, and chapters 2 and 3 will go into a deep dive explanation of what each and every one of those values does. So our risk assessment that we offer, we will go through your system from top to bottom. We evaluate over 100 different items, and we will highlight and evaluate up to 55 different high-risk items and build you a report and a plan to move forward so that you can remediate those and get to a better position. And if that right off the bat is more than you want to do, we always have the free security scan. This runs in less than 30 seconds. It's going to give you a really good feeling about where your system sits, and that feeling might not be great if you've got more red on the board than you have green, but knowing is always better than just hoping for the best. So again, engage with us, do a free security scan at a minimum, know what your system's sitting at so you know how you can get to a better place. So I see we've got a few questions. How do I know who I need to authorize devices to use the limit sec offer value? That is a great question. So what you can do is you can turn auditing on to those users, And through the audit journal, you'll be able to identify what their interactive jobs are and what those device names are that they're using. I would also suggest, if you're not already using named devices, that you create them specifically named devices so that you can allocate those authorities to them and they'll always know what device they're supposed to be using. Another question we have is about moving from 20 to 40. Can you do that without going to 31st? Absolutely. You can move directly from 20 to 40. All of the auditing is in place. You'll be able to see if you have any domain failures, if you have job Ds being exploited, and then of course, you'll want to identify all those profiles that aren't in a SecOffer class that will lose their all object authority. And removing those authorities prior to doing that change and that IPL always puts you in a better position, because going back isn't always as easy as moving forward. So with that, I want to thank everyone for attending today. And if you have any questions, be sure to reach out to us at info@fortra.com.